incandescent light bulb is a rather simple device. Its base has two metal contacts which connect to a metal filament. The electric current's electrons collide with the atoms in the filament, making them vibrate. This energy heats the atoms to 4,000 degrees Fahrenheit, at which temperature they emit visible light. The light bulb factory has two production lines that eventually merge. One prepares the glass bulb, the other makes what's called the mount, the electrical components that go inside it. At the start of the mount line, a machine cuts glass tubing into pieces of specific lengths. The cut tubes land on what's called a glazing wheel that runs them through a gas flame for about 7 seconds. This heats the glass enough to smooth the surface. The glazed tubes now enter what's called a flare-making machine, which heats each tube until the glass is malleable, then stretches one end into a flared shape. The next machine loads two copper lead wires into the flare end. Then it inserts a thin glass cylinder called the exhaust tube. A trip through a series of progressively hotter flames softens the tubes. A press then moves in to squash them, encasing the wires in glass. At the same time, the machine makes a tiny hole in the glass in between the wires. This is to later remove air from inside the bulb. It'll exit via the exhaust tube through this hole. Next, the machine separates the lead wires and forms the ends into hooks. These fasten to the filament, a thin wire coil made of tungsten, a type of metal that holds up well to heat. The machine coats the lead wires in a liquid form of another metal, zirconium. This lengthens their lifespan by making them more resistant to moisture inside the bulb. Like the tubes we've just seen, the bulbs are made of an inexpensive type of glass called soda-lime glass. A machine stamps the top of each bulb with the voltage, the wattage, and the company logo. Opaque light bulbs are simply clear bulbs with an inside coating of synthetic silica, a white powder. The coating machine charges the bulbs to 30,000 volts. Combined with just the right amount of heat, this electrical charge makes a thin layer of powder cling to the glass. A series of flames evaporates moisture and bakes off any impurities. As the two production lines merge, a bulb goes over each mount. Torches then fuse the flared end of the mount to the neck of the bulb. Arms move in and mold the neck to fit inside the bulb's aluminum base. The next machine vacuums out all the air in the bulb and replaces it with pressurized argon gas. This inert gas will resist heat buildup, helping the filament last longer. After bending the lead wires out of the way, torches melt and seal off the glass exhaust tube, locking the argon gas inside. The bulb would now be fully functional if connected to an electric current. But it needs a base in order to screw into the socket of a light fixture. The base is made of aluminum. This machine inserts one of the bulb's lead wires through the middle and solders it in place. It then spot welds the other wire to the side. The result, two base contacts to line up with two socket contacts. On their way to packaging, the bulbs undergo what's called flash testing. Repeated light-ups using a higher voltage each time. This strengthens the filaments inside, making it less likely to break during shipping.